This year has seen rekindled interest by astronomers in just what types of stars are suitable to produce the conditions needed for Earth-like life to develop on planets within their habitable zones. Specifically in the cases of the planets of Trappist 1 and the exoplanet Proxima b, both of which orbit M-type red dwarf stars, the likelihood of an inhabited world around that class of star has been dropping. That has been somewhat of a blow to those hopeful for finding a universe teeming with life. Indeed, the M-type dwarf stars are the most numerous and long-lived type of star in the Milky Way. The problem is in how close in the habitable zones of these stars are. It's so close that it opens up the planets to massive amounts of radiation, which would make it difficult for life to get going. In my last video, I detailed a handful of Earth organisms that can handle very high amounts of radiation, and there are others that can use radiation to their advantage, and there's also always the possibility of ice shell worlds similar to Europa or Enceladus, where life may arise in a red dwarf system, so it may be premature to chalk them up as being entirely uninhabitable, but they aren't ideal by any means. What we do know, however, is that Class G main sequence yellow dwarfs can support life and even civilizations. We know this for sure because, well, we orbit one. Stars like the Sun aren't rare. In fact, Alpha Centauri A, one of the nearest stars to us, is in this class and only a little larger than the Sun. But here is where the tables get turned in life's favor. An extraordinary paper has come out by Manasvi Lingam and Abraham Loeb, link in the description below, that deals a further blow to the habitability of M-type stars, but ends on a rather startling conclusion. The main purpose of the paper was to report on modeling they did for Trappist 1 and Proxima b. They looked at biological diversity and evolution on Earth, and then looked at the conditions present around M-type dwarfs. It wasn't good, and they conclude that it's unlikely for Earth-like worlds around these stars to ever develop life, or at least life as it developed here. Life simply may not have the time to arise on these worlds before their atmospheres are destroyed by the red dwarf. But now to the other conclusion. Obviously, they conclude that other type G stars like the Sun can harbor life, but not all members of that class can, and in specific cases of high-mass Class M red dwarfs, the conditions may become more clement and allow life to arise. But the real shocker is that all type K stars pass muster for being able to harbor life, so much so that they may be better for it than our own Sun, and could, hypothetically, support even more diverse planetary biospheres than Earth has. In other words, Earth may not be the most ideal place in the universe for life to develop and evolve. K-type stars are orange dwarfs that sit between red dwarfs and G-type stars like the Sun. While not as long-lived as the red dwarfs, the K-dwarfs remain stable and live significantly longer than G-type stars like the Sun. The Sun, for example, will spend about 10 billion years total in the main sequence as a yellow dwarf before it expands into a red giant, and we're now approaching the halfway mark there. By comparison, an orange dwarf will spend between 15 and 30 billion years in that stage. That gives life significantly more time to evolve and develop on worlds within the habitable zones of those stars. Time is good for life in general, but also favors the eventual development of intelligence and civilizations. As a result, the authors suggest prioritizing the K and G-type stars when searching for evidence of biospheres on exoplanets. SETI might also take note of that too. Thanks for listening. I am futurist and science fiction author John Michael Gaudier, currently envisioning ancient civilizations orbiting orange suns, and after a series of blows to life around red dwarfs, it's nice to report the opposite for the orange ones. And be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.